Hi everyone, welcome back to Simple GAN. Have you ever wondered how engineers decide the exact thickness of a pipe that carries high-pressure fluids? Is it guesswork? Definitely not. It's a precise calculation, defined by ASME piping codes. In this video, I'll show you how engineers calculate pipe wall thickness using the ASME B31.3 formula step by step. We'll do an example, and by the end, you'll be able to calculate it yourself confidently. Pipe wall thickness is one of the most critical design factors in any plant. A small error can lead to leaks, ruptures, or catastrophic failure. So, we calculate the minimum required wall thickness, the thinnest the pipe can safely be under internal pressure. And then we add safety margins for corrosion and manufacturing tolerances. That's how engineers make sure every pipeline runs safely and efficiently. Now let's look at the formula defined in ASME B31.3. It's used all over the world for process piping design. On-screen text, T equals P times D slash 2 times. Here's what each symbol means. T, minimum required wall thickness. P, design pressure. D, outside diameter of the pipe. S, allowable stress of the material. E, weld joint efficiency. W, weld strength reduction factor. Y, coefficient depending on material and temperature. This simple-looking formula ensures the pipe can withstand internal pressure safely at operating temperature. Visual cue. Show ASME B31.3 reference text label, Para 304.1.2. Let's do a real example. We need to design a 6-inch carbon steel pipe for a design pressure of 20 bar. That's 2 megapascals. On-screen values P equals 2 MPa, D equals 168.3 millimeters. S equals 137 MPa, E equals 1.0, W equals 1.0, Y equals 0.4. Now plug the values into the formula. T equals /2 times. That gives us a result of 1.22 millimeters. That's the minimum pressure thickness required for this pipe. But wait, in real-world applications, we must account for corrosion and manufacturing tolerance. We add these allowances to stay on the safe side. White heavy checkmark corrosion allowance, usually 1.5 millimeters for carbon steel. White heavy checkmark mill tolerance, which is 12.5% of the nominal thickness. So the final required thickness is 1.22 plus 1.5 plus 12.5% is almost equal to 3.0 millimeters. That's our design thickness. Next, we check standard pipe schedules from ASME B36.10. For a 6-inch pipe, the available wall thicknesses are Schedule 10 3.05 millimeters, Schedule 24.78 millimeters, Schedule 47.11 millimeters. Our required thickness is about 3.0 millimeters, so the nearest higher standard is Schedule 10. White heavy checkmark final selection, 6-inch, Schedule 10, ASTM A106 Grade B pipe. Let's summarize everything we learned. Keycap 1 start with the ASME B31.3 formula. Keycap 2 calculate the minimum wall thickness. Keycap 3 add corrosion and manufacturing tolerance. Keycap 4 choose the next higher standard schedule.
And there you have it, a safe, code-compliant, and economical pipe design. If this video helped you understand how engineers determine pipe wall thickness, don't forget to hit the like button, share it with your friends, and subscribe to Simple GAN for more practical engineering content.
See you in the next video. Keep learning, keep designing safely.